I'd like to start off by welcoming Chris Smith and Carol White, both data science managers at Yorkshire Water, who are now going to talk about the application of data science and how it is contributing to Yorkshire Water's leakage ambitions. So, over to you.
Morning all, thank you all for joining us. So yeah, it's Carol White here and Chris Smith from Yorkshire Water, two data science managers. So we're going to talk about the data science journey at Yorkshire Water, where we've come from, where we're heading to, and then also go into some case studies around leakage specifically. So next slide, please, Chris. And another, I've got two intros. Okay, so data science at Yorkshire Water. There are three main areas of data science activity that we do here. So we've evolved from a largely asset analytics team over the last 2 or 3 years to circa 20 data scientists now and their managers. And we support the business across clean water, customer experience, wastewater, HR and finance. So the three main types of activity we do are shown here. So the first is on the left, upskilling and BAU work. So supporting our colleagues across the business as part of a knowledge transfer. That might be things from Excel training, VBA support, partnership working. So if bits of the business have got external consultants in, we want to support on the data science there. We've got mentoring in place and then knowledge transfer for bringing. In the middle there, you can see some examples of our tactical work. So these would be the standalone projects, quite reactive to business need at that point. It might be a dashboard, for example, showing where the volume of our customer calls are coming from and what they're for. It might be a dashboard showing where the night use is across our region. Or as you can see there, some of the maps that we produce as part of our GIS work. And to the right, which is where we've been moving to over the last couple of years, is our strategic work stream. So that's when we can fully productionize our models, make them automated, deploy them into the business so the business can self-serve. Because that middle one there, the tactical, tends to be harder to do. We do it once and then to repeat it is a lot of work. So we're moving to the right there. Next slide, Chris. So how are we going to get there? So we're using lots of techniques like machine learning and AI for predictive modelling. But as Pauline, I think, said, the data is only as good as the data you're putting in. So our data science needs that data kind of to be cleaned and readily accessible. So what we're doing at the minute is building a data-centric organisation. And the main thing we have to get right first is that strategic data platform. And that's going to be pulling in, well, it already is, data from within the company. So we've got customer data, SAP data, rainfall data, but also external data. So thinking broader to open data, and that might be council traffic data, various customer demographic data that's freely available, open source, and we're pulling that into a curated data set. This then enables us to do these business enabling use cases. So these might be efficiency initiatives or more strategic initiatives, and we'll be talking through some examples. But what underpins all of this is we need to get the governance right, the data quality, and form this centre of excellence so that the business truly sees data science and the data-centric hub as critical to delivering these use cases. Next slide, Chris. So how are we getting there? So, as I said, it's been a journey over the last couple of years, but essentially we've been trying to build our key guiding principles. So defining ourselves as this data science hub. So what are those? We need all of the insight that we're delivering to the business to be actionable. It's one thing saying what's happened, but actually what can we do with that information? We're trying to enable strategic change, ensure that our work is sustainable and accessible to all. So making sure that we're delivering pieces of work the business can self-serve to, rather than needing us for every step of the way. And ultimately ensuring it's customer focused. And customers might be internal or external. The way in which we're doing this is by implementing agile delivery. So you can see there in the green and red bar graphs, the agile delivery method is to deliver incrementally through time, which minimises the risk as you deliver a project. And this is a move away from the more standard practice you see in most companies of waterfall delivery. So planning it all in advance and then boom, delivering in one big suite at the end of a project. As part of agile delivery, we have to reprioritise our workload frequently. Business demands, as we all know, ebb and flow. We have more reactive work coming in. So ultimately, we need to make sure we work on the right thing at the right time. And to do this, we then deliver MVPs, so minimal viable products. If a dashboard is required to deliver a type of performance. The minimum dashboard is what you need to get going to have that actionable insight. It's not the all singing, all dancing bells and whistles that ultimately might look better, but doesn't necessarily add value. And as part of this, we need to be adaptive. So we're making sure the team that we've got are all trained in agile delivery and are able to adapt to the changing demands of the wider business. So as I said earlier, we don't just work on the clean water side. So on the right there, you can see a case study of something we've recently delivered through this approach. So we've just built a natural language processing model, so that's machine learning, to capture how our customers are feeling from their written feedback. So now it's fully automated into our strategic data platform. No longer does somebody need to download, say, 100 customer feedback texts, run it through the model and spit out how those 100 customers were feeling at that time. The customer feedback is flowing straight into the strategic data program and spitting out into a Powered BI dashboard, which can be updated daily or more frequently if required to show how our customers are feeling. We can break that down and then into different areas of the business. So how are customers feeling on a particular journey? So for example, if they have had a leakage journey or an ISF, internal sewer flooding journey, how has their emotion changed during that time? And it moves further from going to scores of 1 to 5, the 1 being that wasn't great, please do better, and 5 of that was excellent. We've been able to employ machine learning to understand from the words our customers are using, not just if they're happy or sad, but if they're frustrated, disappointed, there's a lack of trust perhaps, or maybe they're surprised and excited by something, which is, I'm sure, hard to imagine from a leakage journey, but there will be journeys across the wider water networks journey that will have elements of those things in there. So before we move on to the case studies around leakage, the key considerations in setting up a data-centric organisation are listed there. So the technical enablers. Do you have the technology in place? Do you have the right people in place to get your data into a data lake? That's one of the big things Yorkshire Water's worked to overcome over the last couple of years. How will you deliver to multiple streams? So your data science team are likely to be delivering to more than just leakage. So how should they be set up to deliver across the business? How do you prioritize this workload coming from competing areas of the business? So the key bit there is for all business cases to have benefit attached to them. What will they deliver tangibly? Is it a reduction in contacts, a reduction in leakage, or reduction in sewer flooding events, for example? And ultimately, it's getting that data ownership and governance from the business as a whole. Your customer teams need to be willing for you to work on live customer data and the risks that come with that. So I've just seen Chris's camera's gone off, so I hope he's still there to pick up the next bit, which will be around the specific leakage examples.
Yes, I'm still here. Hopefully you can see me. So let me just get this going. Yeah, so thanks, Carol. So yeah, my name's Chris Smith. I'm a data science manager at Yorkshire Water, so the same role as Carol. My team have historically focused on the clean water side of our business, so everything from water production through to leakage and distribution. And so what I'm going to talk through today, a couple of examples of pieces of work that we've done in collaboration with the leakage team in the past. So a lot of these pieces of work will more readily fit into that sort of tactical arena. So bits that we're doing with the team to address sort of immediate issues, but then start to have an eye on that more strategic delivery. How do we sort of get to those more sustainable benefits? So as I run through these examples, I'm going to be focusing less on the methodology, the specific methodology we used or the specific results we saw at Yorkshire Water, and talk more generally about the value of doing this type of work and also the key considerations that we need to be factoring in once we look at it. So hopefully you'll leave this session when you get back to the virtual office on Wednesday. You can start firing off emails to your internal data science team, internal analysis team, start pestering them for support in this type of arena, unless you work for Yorkshire Water, of course, in which case you can ask politely. So yeah, the first one, really common piece of analysis that we're asked to do is just around benefit assessment. So quantifying the benefit we realize from existing approaches, new approaches, bits of innovation. How is that impacting our leakage performance? How is that improving our efficiency? How is that improving our ability to meet our stretching targets? So really common, like I say, we do similar analysis in all areas of operational performance. And the reason we do it is quite obvious. Obviously, it's important to understand how effective, how valuable our leakage management activity is. How does it compare across different approaches, different techniques? When you're bringing in new technology, how does that impact that performance as well? Central to sort of the current AMP and the challenge, how does that performance deteriorate, or the benefit diminish as leakage is driven down? So it's important that we continue to monitor where our performance is now, and then as we progress to lower and lower levels of leakage, how is that changing? And is it changing consistently across the region, or are we seeing differences start to appear? So the map you can see in the top left-hand corner there, that's a map of Yorkshire based on normalised leakage performance. And the eye can quite clearly see there's a big difference between how our leakage performs in the more urban areas, so in the south and the west, places like Leeds, Sheffield, Huddersfield, sort of big operational challenges there. And leakage tends to perform significantly differently, in most cases better, in the more rural sort of northern and eastern parts of Yorkshire. So it's important that we acknowledge that we don't have a common leakage challenge across our region. We need to understand how the different processes perform in different areas linked to different challenges. This type of work is also really critical in establishing the cost benefit of new proposed solutions. So new investment in telemetry, new capital solutions, be it pressure optimization or renewal schemes. Does the benefit we see, either as part of a trial or a proof of concept, or the benefit that we can project, does that justify the investment? Does it justify in AMP? Do we have to cost that over several AMPs to get that benefit? Obviously, central to answering those questions is understanding the value of that solution. Once you understand the value, particularly if you're looking at a trial or a proof of concept, you need to start establishing it. That's what I've observed in that area. What's the full potential for the region? Does that can we extrapolate that linearly, or do we expect that to sort of be exponential in the sense that we expect sort of that sort of 80-20 rule where we see the majority of the benefit in the sort of the a limited deployment and then that diminishing quite quickly? So again, these are the types of questions that we've been working to support. And then finally, obviously, once you understand how effective your current process is, you can start identifying where those differences are and start thinking, right, how do I improve? How do I improve the benefit realized through existing processes? Or how do we take what was observed in a trial and realize additional benefits as well? So really fundamental questions that we've been supporting the team in answering. The key bits to consider when you're approaching analysis of this type, firstly and fundamentally, leakage is a very transient thing. It changes daily. It's you know, if you would have looked at the leakage position a couple of months ago versus where we are now with the weather we've had, they're completely different. And it seems obvious, but it's really important to consider when you're doing a benefit assessment, where are you sort of defining that start and end period? Because the leakage performance you're looking at, particularly over several months, could have changed significantly. So one way around that is to use a control area. So you've got a trial area where you're trying a new technique, trying a new technology. Can you find a control area that's relying on more traditional approaches, that's comparable in terms of where it is geographically, how it's built up in terms of mains material, pressure, etc. And you can observe the difference in the way leakage performs in those two areas and understand what is this additional approach giving me in that trial area that I'm not observing in the control area. So as an example of that, if you look in the top right, what you can see is performance that we observed as part of our acoustic logging trial that we implemented a couple of years ago. So before we did a large scale deployment, obviously we did a more focused trial to understand the benefit of that technology. The blue line is the observed leakage performance in that trial area. And if you look at that, you can see that leakage is going down slightly, but it's relatively flat for the majority of the year, which you could argue that hasn't realized much benefit. But when we bring in the predicted performance, so what you can see in that dotted black line, that's based on what was observed in the control area, what was observed historically in those DMAs, which tended to be sort of highly reactive, high rate natural rate of rise DMAs. You can actually see that there was quite a significant change in performance as a result of that technology and as a result of that trial. So that brings us to the second point, which is just about understanding that trial versus business as usual. So using those control areas to quantify benefit, understanding what the technology is giving you beyond what you would have observed anyway. It's also important to consider, does that trial represent what business as usual is going to look like following full deployment? So often with a trial, you're looking at a small area, often with a dedicated team. It's new, it's shiny, they're wanting to react to all the potential insights that are coming from that technology or that approach. So it's just that word of caution to say, is it perfectly translatable to, this is what was observed during that trial, to full deployment? And then the final point that also links to that is just about understanding the attributes that determine benefit. So if you're looking at that trial or proof of concept approach, does that area reflect the rest of your region? And does the benefit you see in that area, is that determined by the makeup of the area? So in that acoustic logging example, picked areas of high failure, high proportion of cast iron mains. If we take the benefit observed there and just multiplied it by the whole region, that probably wouldn't be legitimate, because obviously you're seeing a greater benefit in more reactive areas, and obviously the benefit observed changes based on the material type. So again, just taking the effort to understand the factors that may influence the benefit that you see is important when you're scaling that benefit up. So next one, so that was about hindsight, so observing performance as part of trials. This is more about foresight, so getting into understanding how leakage performance is likely to pan out over the course of a year, over the course of an AMP, and obviously using statistical models to try and forecast performance. So leakage is very seasonal, leakage is very volatile, it's very influenced by external factors. That makes it perfectly suited to forecasting approaches. That seasonality, that volatility, you can pick that up, you can quantify it, and you can reflect it in forecasts. Obviously, it's not an exact science, but it's definitely an area that we've been exploring extensively, and I'm sure it is been explored across the industry as well. So hopefully the benefits of forecasting are fairly self-explanatory. Obviously, they help you with your business planning, understanding what level of investment, what level of resource, what the leakage challenge looks like, both in year and across the AMP. It's important in determining operational targets. So obviously, leakage is very volatile. A lot of the risk exists in the winter. I'm sure many of us are feeling that now. And it's about understanding, based on the range of results that I can potentially expect to see in my winter performance, what level of headroom should I be driving for when things are a little bit quieter on the leakage front? So making sure that the operational targets are responsive to that range of risks that exists at the back end of the year. And linked to that, obviously, as we progress through into the winter period and summer as well, to a lesser extent, it's about monitoring that risk as it develops, and obviously understanding how that could potentially impact that in-year and that 3-year rolling performance as well. So in terms of delivering forecasting, it's important to obviously understand the relationship between those external factors and leakage, and try to quantify them. So temperature, rainfall, soil moisture deficit, customer behavior, these are all factors that matter and can be observed to matter to leakage performance. So lots of work in understanding the relationships there. There's a couple of examples. Say in the top right, you can see that's the correlation between the minimum temperature in winter and the number of reactive mains failures. So you can see that relationship where colder temperature equals greater mains failure. No surprises there. We've replicated similar analysis looking at soil moisture deficit in the summer period, and that's really solidified our understanding of the different factors that influence our performance. So linked to what I was talking about before in terms of benefit, when you're forecasting, particularly over an AMP where you need to see leakage improve significantly, it's important that you reflect that benefit in your forecast. So how many resources are you going to be employing? What benefits you're expecting to see from capital activity? What benefits you're expecting to see from innovation? Include that in the forecast. And obviously, what's important to recognize there is also volatility in the benefit you realize. So make sure that benefit is captured in the forecast, and that really really sort of comes on to that last point there, embracing that uncertainty. We can't predict the weather. We can't predict, you know, is it still going to be snowing in a week's time? Is it still going to be snowing in a couple of weeks' time, in a month's time? We don't know these things, but if you create forecasts that reflect the range of outcomes that you could expect to see, and a good approach for that is Monte Carlo analysis, where you basically simulate multiple future scenarios, and then you understand the distribution of those scenarios following that process. Really crucial in leakage and across the range of our operations as well. So a final one for me, and this is where we get into more of the strategic work that Carol alluded to. This is really central to what the strategic data platform can enable us to do. And I'm you know, it's already come up a couple of times in the various discussions. The idea of a situational awareness digital twin, getting those insights, getting those analytically derived decisions, getting them embedded in the day-to-day operation of the business. Sounds easy. It's very difficult. It takes a lot of investment in IT architecture and infrastructure. It takes a lot of investment in sort of analysis and understanding benefits and how to sort of play that out in real time. But this is where the sort of the biggest gains are likely to be found in terms of sort of realizing improvement in efficiency. So essentially where analytics comes in, most obviously it's about assisting in that decision-making process. So one of the things that we've been looking at over the last couple of years is using analytically derived insights to drive or determine where we send our leakage resource. So obviously we've got a finite level of resource, quite a vast operational area. Where's the most beneficial areas to send them? Where's the most beneficial areas to prioritize in terms of leakage activity? And it's not necessarily just the ones with the most leakage. It's about understanding the nature of that leakage. So how do we typically perform in an area that is gradually rising versus one which is broken out? How have we performed in certain areas which are more stubborn? So we've invested a lot of effort, a lot of activity in that area, and yet we're not quite seeing the results. What's the factors that determine those areas, and how do we get them reflected? So when they come up for prioritization, we're not just repeating the same activity in the past that hasn't yielded the benefit we'd expect. So identifying those problem areas and sort of promoting them for a different route of escalation. Obviously, you can also start to bring in performance indicators. So understanding, are we targeting the right areas? How successful have we been in realizing the benefit that we'd expect to see? How is that differing across different regions, and really equipping the leakage management teams and operations with that insight into their own performance to drive improvements. Key considerations when you're trying to deliver this, obviously, Carol already alluded to it. It would be very difficult to deliver this type of activity with that sort of traditional waterfall approach. That approach whereby you have to sort of really define what it is I'm going to deliver, what's going to add value, what do the leakage teams need to see. I can't see how that can be delivered effectively through waterfall. That agile approach of delivering little and often, give the team something, that minimum viable product to play with, understand if it's adding value. If it isn't, look to build upon it, trying to change things, and obviously sort of build a solution with them over time that evolves. Often with these things, once a dashboard gets to a point where it stops evolving and stops sort of you stop hearing from the leakage team about what they want to see, what it needs to give them, that's often when it's sort of tailing into sort of it's dying basically. So it's good to have those constant conversations, trying to evolve with the process. Just finally, just conscious of time, trying to incorporate those benefits. So understanding where we see benefit versus how a DMA looks like in the moment, and sort of reflecting that. Integrated view of the network, so bringing in all these new sources of information, new bits of telemetry, bits from customers, bits from social media, bringing them all together in a view that equips people to make the best decisions at that time. And obviously the importance of having that data available and accurate, but also the speed of that data. This is the challenge that we've had without the strategic data platform, is producing this information in a way that's quick enough that it's meaningful for the leakage team, and we're not sort of lagging behind them. We're giving them what they need in the moment, and they can act upon that immediately. So that's it from me. I hope you found that useful. yeah, if you've got any questions, obviously there's a Q&A after this that we can.
Okay, I would say
you.
thank you, Chris and Carol. I'm keeping an eye on time.